Today in part 6 of arc properties we will be doing the theorem number 6. Again I will tell you, this numbering is for our convenience sake. The theorems have no numbers. Anyway, in the last class, that is in the last 5 parts, whatever we have done, let me just brush up once again for your memory's sake, so that by revising you will remember the theorems also. The first 5 are one by one. I am just stating the statements. The first one is the perpendicular drawn from the center of a circle to a chord bisects the chord. The converse of it is the line joining the center of a circle to the midpoint of a chord is perpendicular to it. Then we have the next theorem, that is the the third theorem was the angle made by an arc. No, sorry, this was not our third theorem, but that makes no difference. Let us revise what all we have done. The third one that we have done is the equal chords are equidistant from the center of a circle. Then we have done equidistant chords are equal. Then we have done the arc property. The first one, the angle subtended by an arc at the center of a circle is double the angle subtended by it in the remaining part of the circle. Now the next, that is the part 6 arc properties. Part 6 and theorem 6, and this is our circles chapter 18. Now this theorem states that angles in the same segment are equal. Okay, under arc properties, the first one that we learnt is the angle subtended by an arc at the center is double the angle subtended by it in the remaining part of the circle, which is a very important theorem, very often used theorem. Okay, now we will be doing angles in the same segment are equal. I have already told you that what is a segment? A segment is the region bound by an arc of a circle, say AB, and the chord. So this is the segment. Okay, so this is the minor segment and this is the major segment. So this is one segment, this is another segment. So now according to this theorem, it says angles in a segment are equal. Okay, so that means AB is a chord and this is the major arc, so the region is major segment. Now angles in this segment means the angle, say, subtended by the arc at a point C, then take another angle subtended by an arc at the point D. According to this theorem, these two angles will be equal, right? So very easy to prove using our previous knowledge. Now we have already learnt in the earlier theorem that the angle subtended by an arc at the center of a circle, that is say O, say that is in this figure it is AOB. Okay, now this angle is twice the angle subtended by the arc in the remaining part of the circle. So angle ACB and angle ACD are the angles subtended by the same arc in the remaining part of the circle, that is in this, and the angle subtended by the arc AB at the center is AOB. So AOB is twice angle ACB and AOB is also twice angle ADB. So therefore angle ACB is half of angle AOB and angle ADB is also half of angle AOB. So they are equal. So let us write what is given to us. Given to us angle, two angles are given to us, angle ACD and angle ACB. Angle ACB and angle ADB subtended by an arc at C and D. Okay, in the major segment you can say. Okay, now we have to prove that these two are equal, angle ACB and angle ADB. So for that, as I told you, we assume that angle AOB is the angle subtended. We assume means we draw. Okay, it is not given to us, but we are drawing. So what is, first of all, what is to prove? To prove is angle ACB is equal to angle ADB. In order to prove this, let us do some construction. Join. So what we are doing should be in dotted lines or broken lines. Okay. So join OA and OB. So now proof. Angle AOB is the angle subtended by the arc AB at the center O. By the arc at the center O. Now, so according to our previous theorem, implies angle AOB is equal to twice angle ACD, and angle AOB is equal to also angle AOB is equal to twice angle ADB. Okay, angle AOB is equal to twice angle ACB and angle AOB is equal to twice angle ADB. What is the reason? The angle at the center, is double the angle in the remaining part of the circle. Okay, so that is why. So this implies that angle ACB is equal to half of angle AOB and angle ADB is equal to half of angle AOB. Now suppose this is 1 and this is 2. So 1 and 2 imply that angle ACB is equal to angle ADB. So that is what angles in the same segment are equal. So that means this is also proved universally and we have also proved to ourselves. So we are free to use this theorem in any circle. In any circle this is true. Not only in the major segment, even in the other opposite segment also. If you take any 2 points here, say EF. So angle AEB and angle AFB, these two also will be equal according to this theorem. So we have successfully proved that angles in the same segment are equal. This is also very often used. These are very, very important theorems which we will use very often to solve other problems that will be given to us. So is it clear, children? Okay.